Good morning, everybody. My name is Lori Kerrigan. I work with Monroe County Conservation District, and welcome to the Big Picture Workshop. I'm glad you guys could all come today. We have some really good speakers for you all today, and I hope you enjoy the day. Just some logistics to get out of the way. Obviously, you all found the coffee and the food in the back of the room. Lunch will be served around noon. There'll be snacks and coffee and everything throughout the day. If anything's missing, just see me, and we'll get you what you need. Bathrooms are down the long hallway as you exit the doors. They're just to your right. NCC is a non-smoking facility, so they've asked if you do care to smoke. There's a gazebo just across the way. Please just respect that for them. Let's see, we are recording today's event, so you can just speak loudly if you have any questions or anything. Our presenters will be repeating the questions. We do have microphones too. If you care to, Craig, we can hand you the mic. So let's see what else. There is free Wi-Fi here. NCC, there is no passcode, so just go ahead and feel free to log on to that. All of the presentation handouts are on our website. That's mcconservation.org. If you didn't get a chance to print them out ahead of time and you want to follow along, you can download those. And the presentations will be posted to our website afterwards. We'll upload those so you can view them again. Let's see, anything else? So I will just introduce our first speaker. Is coming to us from Gorham, Maine. His name is Mr. Rob Woodman. And a little bit about Rob. He graduated in civil engineering from the University of Wollongong, Australia. He spent the first 10 years in design and project engineering for private engineering consulting firm and a wide variety of civil and stormwater engineering projects throughout New England. Rob now serves Acf Environmental as a senior stormwater engineer and supports engineers, landscape architects, and designers on site development and green infrastructure systems from Maine to Maryland, overcoming design and permitting challenges with a suite of innovative solutions. He's a registered engineer in both Maine and Pennsylvania, a certified professional in stormwater erosion and sediment control, Maine DEP certified stormwater inspector, master gardener, and entrepreneur. Rob, as I said, lives in Gorham, Maine with his wife Jessie and 4 children under 11. So if you guys would all please welcome Rob.
Get this right today. Perfect. Good morning. My name is Rob Woodman, as you just heard, and I work as the Senior Stormwater Engineer for Acf Environmental. Acf Environmental is a innovative construction products company, and we have a booth out there, so you can go and talk to my colleague Dan or myself about any of our solutions later on. Today's kind of fun. I'm not going to be talking about products. I'm going to be talking about the importance of collaboration, specifically in green infrastructure projects, from design all the way through to post-installation. The concept of collaboration is a very simple concept, so nothing that I'm going to throw out today is probably going to seem particularly novel to you. However, it seems as humans that we seem to avoid collaboration. We like to kind of get things done on our own and pedal forward, whether that's in work, whether that's in our personal lives or whatnot. Yet the beauty of collaboration can really bring a lot of benefits to projects when it comes to green infrastructure and regular site development projects. And my goal today is to provide sort of a framework for maybe thinking through how you, as designers, landscape architects, contractors, municipal folks, conservationists, how you can be maybe the spearhead behind initiating collaboration or being the chief collaborator in projects that you have moving forward. So before I do that, show of hands, who in the room are civil engineers today? Okay, whoa, stacked on the civil engineers. All right, landscape architects? All right, we got 1 down the front. You can put your hand up high. There we go, boom. That's good. And contractors in the room? Okay. Okay, interesting. So we did this yesterday too, and there was a much more even spread actually amongst people here. And those who work township folks or government, municipal, all right, and conservation district folks, obviously stacked over on the bench here as well, a few at the back. Okay, great. All right. Biologists, thank you. Sorry, I will forget some, and there's probably some others out there too. And my goal is to not offend any one particular group too many times as we go through this today. So ACF, the company I work for, we're Maine to Florida. So we got yards up and down the East Coast. We've been around for about 33 years. We're really the early adopters of geosynthetics and innovative applications, the creators of the dirt bag and really exciting BMPs with really cool names. We're distributors, we're manufacturers, and we make a lot of stuff. We sort of like to say that we sell systems, not just products, and you'll see elements of the kind of system approach we have as I go through some of the case studies today. The reason I show this on the board is that I get to work from Maine to Maryland, as was mentioned in my introduction. And what's really interesting from Maine to Maryland, there are so many different things going on when it comes to site development projects. Regulations are different, so different. Even from Maine to Massachusetts, totally different approach to stormwater management, which is crazy when you think it all being is part of the same EPA region in a lot of cases. But different soil conditions, different challenges, different experiences with green infrastructure, some of the early adopters versus some folks who may be catching up later on. So it's a very unique role I get to do, where I get to see a lot of different things that are happening and see programs that are doing well and ones that are doing not so well. And the ones that are doing well are generally where collaboration is alive and well. So I get to work with exciting things, like I said, sediment control, all the things we think about late at night and into the weekends, silt fence, silt sacks, and dirt bags, like I said, which was named after one of my colleagues a while back. Erosion prevention, so ECBs, TRMs, ACBs, geotechnical stabilization, grids, geotextiles, green walls, innovative aggregates, stream bank protection. We're seeing this obviously more as it relates to the MS4 world these days, with either green slopes, with either just protecting or providing slope stability solutions in the green space, as well as the hard armor solutions. So these are the types of things I get to dabble in. And on the stormwater side, a whole bunch of different kind of solutions, from storage to green infrastructure to permeable surfaces and all kinds of filters. And the reason I throw that on the board is that a lot of these different pieces sort of work in concert with one another when it comes to solving challenges in the green infrastructure space. But enough about that. Today we're going to talk about collaboration. The importance of collaboration as it relates to just general site development projects, and also specifically some of the challenges with green infrastructure endeavors or low impact developments. Touch on collaboration in design, and I'll go through a number of projects in the grant funded space. A couple of New England projects that I can share with you, a redevelopment project that's happening in the city of Baltimore. Talk about the construction, collaboration in construction, which is a very important part of this process if we're going to see our designs come to life in the field and be built the way we want them to be built. And then at the end, just touch on a couple of programs that I get to sort of experience and rub off on or deal with sort of passively in the city of Philadelphia, and also a project I'm working on in Reston, Virginia with the ASC headquarters at AGI retrofit. So that's kind of where we're heading. If anything sounds preposterous to you, you can leave at any time, but that's where we're going. So collaboration. This word has a lot of different terms, a very flexible term, and as I started thinking through this concept as being part of so many different projects and seeing the ups and downs and the strengths and weaknesses of the collaborative effort, I searched far and wide for a definition for collaboration, and this is what I have for you today. So collaborate, this is going to be our reference point for today. A purposeful relationship in which all parties strategically choose to cooperate in order to achieve shared or overlapping objectives. So I'll say that again, and different words will stick out to you. For those who enjoy social activities, parties will obviously stand out. The word choose is a very big part of this as well. So a purposeful relationship in which all parties strategically choose to cooperate in order to achieve shared or overlapping objectives. Not necessarily the same objectives, but overlapping objectives. So when we talk about the parties in any kind of site development project, who are these parties? A lot of different players here. We've got the owner, maybe the owner's rep during construction. We've got a conservation district. We might have a municipal or a township engineer. On the design side, we might have an architect, a landscape architect, a civil site engineer. You'll see I put the landscape architect ahead of the civil site engineer, so you can enjoy that moment there. Mechanical and plumbing engineer, structural engineer, general contractor, site contractor, landscape contractor, distributors, crazy folks like myself, building trade contractors, and then we get into ownership, property management, what's going to look like to actually run these sites, and then the users. So maybe us, as we enjoy this facility here or at your office complex or your kids in school, their experience of these sites post installation. That's a lot of people there, right? And the idea of those all collaborating together is a pretty big ask, right? But what's interesting is all these different parties are interconnected in various ways, but we don't always collaborate as well as we could. And why is that? So I've thought through this question, and here are a couple of ideas I have. Why don't we strategically choose to cooperate in order to achieve shared or overlapping objectives? Here's a couple of thoughts. Developers want to save money and maybe take permit level plans to construction. We see that a lot today, 50% DD plans hitting the street for pricing. And then on the downside, unfortunately, contractors have to price that, and then they're told 6 months later when the plans have evolved to be about threefold what they were at that time that they have to honor their price. It's a tough ask. The engineer of record is often not engaged during construction. We're seeing this more and more. 10 years ago, part of your services would be to design and permit the project and then be out in the field assisting and providing some oversight during construction. Now we think we can cut costs and save money on a project by not doing that. Maybe, maybe not. But then often the engineer of record comes back at the end to do a punch list after not being part of the entire process, and then the finger pointing starts with, well, that's not what that was meant to look like. Young engineers are spending less time on site. So again, 10, 15 years ago, every site, when I started working as a young consulting engineer, my boss required me to go to the site before I even touched pen to paper. So I'd end up in these like wooded sites in Maine being like, oh, it looks good. I don't know. And I'd go back to the office and then I could actually pick up a pen and start working on it. But we're not spending as much time. We have these details that look great on plan, but are we actually using common sense in the field to make those details more realistic for contractors to build? Civil engineers generally avoid landscape architects. And then on the flip, landscape architects, I'm seeing in return, generally try to avoid civil engineers. And with regards to civil engineers avoiding landscape architects, I mean, so often, you're working up to this deadline as a civil engineer to get a permit done, and then the last 3 hours, you call the landscape architect, and you're like, I need you to throw some trees on this plan. And they're like, well, what kind of trees do you want? Just throw some on there. Okay, well, what are they going? It doesn't matter. I need to get my permit, throw a couple of trees on there. You may have all experienced that, depending on how you collaborate with your landscape architects. It's really not fair. And then we get out in the field, and we're like, man, why is this tree not doing so well in 6 inches of engineered soil media? Contractors not engaged during the design process. This is sort of flips things upside down a little bit, but what I found since not just working as a consultant, but now out in the field, spending a lot of time with contractors, seeing the systems go on the ground, so there's a lot of really good common sense that comes from contractors in the field that voice doesn't get back to the design process. So you might learn something in the field and say, hey man, why are we designing it like this? Why is this detail like this? We could do it much more efficiently, maybe much more cost effectively, maybe even get better performance out of it if we did it this way. But those contractors then don't have a voice at the table for the next design, and so that information is lost, and we keep doing the same thing over and over and over again and expecting a different result. Owners maybe aren't fully informed about the cost of long-term maintenance or the cost of ownership. Maybe they don't want to hear about the concept of maintenance. Maybe they don't want to assign any money to the concept of maintenance. But at the end of the day, we might find the perfect BMP, whether it's stuff that I work with or any kind of other BMP, as an engineer and say, this is great, this is going to meet all permitting requirements. But is the owner aware of what it looks like to actually own that post-construction? Construction phasing, coordination of trades. And then what I'll touch on late in this presentation is the voice of lessons learned from maintenance being brought back to the design. And I'll highlight this in Philadelphia later on, but we get out there in the field and we install these systems, we complete the project, everybody moves on, occupancy permit is achieved, and then there's a thing called maintenance. And sometimes maintenance contractors come out and have some really interesting thoughts about maybe different ways we could be maintaining these systems, or way we could maybe design systems to avoid the frequency of maintenance or the cost of maintenance, or at least reduce that. Unfortunately, that voice often doesn't get back to design either. In green infrastructure, there's added complexities. We have to deal with often tight spaces. These are generally urban retrofits, where maybe we're digging into a sidewalk, have a very limited space between face of curb and face of building. Working around existing infrastructure. You don't see this too much in Maine, but obviously as you get into slightly more cityscape areas, the chances of hitting an unexpected utility, particularly in retrofit work where maybe the same kind of due diligence isn't done up front with survey work, coming across unexpected utilities, how do we work around those? In green infrastructure, a lot of these projects also affect local business. So it's great to be able to plonk a right-of-way bioswale in front of a little strip mall, but does the strip mall know about that? How do they feel about maybe business being affected during the period of construction? So that's an element of collaboration and coordination that needs to be achieved. There's an abutters and a public process. A lot of these green infrastructure projects have a lot of folks looking in on them with various opinions as to whether green infrastructure is something they like or they dislike. The green infrastructure projects also often have metrics for long-term monitoring and performance. So it's not just throw this thing in the ground, but is it actually improving water quality at the bottom line? Aesthetics and maintenance. So the idea of not just function from the engineering side, but also it being a feature is also a much bigger part of green infrastructure. In certain site development projects, you can put some kind of wet pond in behind a building and no one really cares too much about it. But in green infrastructure, again, it's usually tight spaces, usually right around residential or commercial or infill business, and it has to look good too for green infrastructure to keep moving forward. And unfortunately, in green infrastructure as well, we don't see a lot of collaboration between the design team and the folks building it. And because of that, there's a lot of finger pointing that we see at the contractor post-installation. But is that finger pointing justified? All the engineers are like, yes, it is. I'm going to finger point all day long. But do we do the best job we could as designers to get these contractors set up for success? Maybe we do, and maybe we don't. When we think about a rain garden, we do these designs and work with a landscape architect. We have this design that looks something like the image you see on the board right there. That's what we think it's going to be. And then we get out there 12 months later and we see this. And I'm sure some of you have experienced this in the bioretention world, the rain garden world, the microbiome world from like Maryland, under-drain soil filters, constructed filters in PA. And we step back and say, man, what did the contractor do wrong out here? And hey, there may have been some mishaps during that process. But if we look at the sections that we put on, and we're so used to just grabbing either from the state manual or the local manual, or maybe something that someone in our office has done previously, have we done the best job we could in specifying each of the different components of this system to set it up for success? Let's take a look at this one. We start at the top to bottom. So organic mulch. Organic mulch is a very generic term that could mean a lot of different things. Is that softwood? Is that hardwood mulch? Is that diligently screened, or is there a lot of fines in that mulch that are going to clog the system from the get-go and not even let water through that surface layer? Is that a bag of red mulch from a Home Depot, or is that something that's specially sourced from a landscape yard? We get to the media. 24, in this case, it says 24 inches of planting soil medium. It can mean a lot of different things. Is that a rich organic soil, planting soil with a bunch of clay content and fines? Or is that a fast-draining, sandy kind of material with a little bit of organics to kind of allow for some plant life? What does that mean? We've got to do a good job speccing that. Is that a fast-draining material? Is that a slow-draining material? And that also ties into, is that the right material for certain types of plants? Trees, or should it just be shrubs, depending on the depth and the type of material in there? Also, when it comes to water quality, what are we using for our organic content? If you think about a lot of the research out there from ASCE and their BMP database, the compost-based medias are showing to release a lot more nutrients than they're actually pulling out. So you might put in the system, it might drain fine, but are we actually improving water quality at the downstream end? We might actually be leaching out more nitrogen and phosphorus than we thought we were pulling out of the system. So something to think about. Does it work, or does it actually work for the purposes of water quality? Is that material mixed in the field? Is that sourced from somewhere special? Are we actually testing that material to make sure it drains and make sure it has appropriate water quality? Something to think through. When we get into the sub-base materials or the stone lay with the underdrain, you'll see here it says a geotextile wrap on all sides. For those who have been in the construction industry for a while, you know that there's a lot of different geotextiles out there. I joked yesterday that, that obviously the clothing that we're wearing today, geotextiles, even these pink pants, and one might say that my wife and I need to collaborate more on my fashion sense. But these are all geotextiles, and you're not going to wrap an underdrain with your shirt. You might if you're really desperate and you're running out of material on site, but probably not going to happen. So what is that geotextile? And, when I was working as a civil engineer, I wrapped everything in Mirify 140N. That's just what I did. Everything. Need fabric, 140N. 140N. I probably made Mirify a ton of money over about 10 years using their fabric in absolutely the wrong applications every single time. That's a great 3.5 ounce separation material, but that may not be the material that you need for your application. So when you're doing, a detention system that doesn't need to be formally lined, a non-woven is a good material, but usually not a 3.5, usually like an 8 ounce, so it's a little beefier, it can hold up to the installation. When you're doing infiltration, we generally use woven monofilament fabrics. They have similar drainage passage than a non-woven, but they're less susceptible to clogging. So something to think about for infiltration. It's not just a fabric. What kind of fabric is that? Obviously, then you have liners and all kinds of other things. We even use a material called a microgrid that Centene makes. It's called SR18, and it's sort of a small biaxial geogrid. It's a really good clog-proof layer when you're wrapping like a stone envelope and just want some basic separation. So important to be thinking through these things, and it's kind of funny to look at, but I'm sure we've all been guilty of just grabbing a detail, plunking on a plan, and maybe not thinking through these individual components. In Maryland, they have a BMP called the Landscape Infiltration Facility, and they actually put 2 layers of fabric through this BMP. So if you spec the right fabric and happen to get particles through, or water through that first layer, it's kind of like a game show for BMPs. Then you've got another layer to try to make your way through. And most of the BMPs, we're seeing a lot of manuals, and PA fits into this somewhat. We're starting to see them move away from geotextiles altogether and just have a smart transition layer from a finer material to a coarser material as you transition to the underdrain layer. So just be thinking through this. Is the geotextile necessary? And if it is, what kind of geotextile do I want to use? Then we get to plantings. Plant health. What kind of plants are appropriate for these types of medias? If you have 18 inches of sort of high flow media or sandier material, it's probably not the place you want to put in a nice big tree that has a 2-foot root ball on it. It's not going to do well. It's not going to survive. It's not going to thrive in that environment. But trees obviously want a nice, rich, deep planting soil. So maybe there's opportunities to do trees beside our bioretention system, but maybe not right in it. And maybe in the bioretention system itself, we do smaller shrubs, perennial grasses, black-eyed Susans, daylilies, these types of things. Native plants, of course, as you'll hear about a little bit later on. But these are important things to think about, because if we don't do that, we'll get into some issues. A little note on civil engineers versus landscape architects, a classic battle historically noted for decades. The civil engineering plan can be kind of simple and boring and geometric. And oftentimes when civil engineers design these systems, there's a missed opportunity for function and feature. And everyone has a different appeal and aesthetic for different things. But here's a classic civil engineering system. It's a perfect rectangle of mulch. I went out there with a protractor and made sure it was exactly 90 degrees. So everyone in this room who raised their hand for the civil engineer category would be pleased. And there's one plant species, and it's perfectly laid out in rows and lines. Well done. Well done. A civil engineer was here. The next one, plants were just optional, and we decided to beef up the riprap just to make sure that, again, we knew a civil engineer had been there. And these maybe aren't what folks are thinking of when we present this great plan for green infrastructure to a municipality as the future. But let's flip it around. Landscape plan can sometimes be a little complex with too many species and maybe adds complexity to maintenance. So while this looks nice, unless you have a very qualified contractor coming in to maintain this thing, they'll either kind of freak out and walk away, or deadhead the whole thing thinking that it might all be weeds. Neither of those are probably acceptable reactions. So a lot of the research I'm seeing out there and some of the papers I've seen recently on LinkedIn sort of suggest that 3 to 4 kind of plant species with a little different variation in height, seasonal color, these types of things might be the right kind of mix for a rain garden that's there for treating water or a bioretention system, and then spaced appropriately so you have room to access and maintain and clean that media surface. So when collaboration is done poorly in green infrastructure, and you can see some of these amazing photos down the bottom that hopefully none of you ever have to experience. Those are all post-construction. We get frustrated owners. We get frustrated contractors. We get frustrated engineers. Frustrated owners because this is not what they thought they were buying and they've already maybe paid for. Frustrated contractors because perhaps they put in a really good effort and the detail was destining them for disaster from the outset, and they're now getting the finger pointed at who's going to dig this out, who's going to fix it, this is not what I was looking for. Frustrated engineers, because obviously as engineers we want to be proud of what we design and see it function and be the way it was intended in the field. Frustrated landscape architects, as you can see in every application here, the landscape architect is not built up. Frustrated public. Because folks are buying into this concept of putting something maybe a little unusual in their right-of-way or in their frontage, and maybe got really excited about it. And those who are, wearing the green infrastructure hat are out there on the street telling people about it, getting them excited. And now they've got to somehow defend what this is. So this is not good. It's not good on all levels, and in particular, it's really not good for the future of green infrastructure in that particular region. Because sometimes it only takes one bad project. And that can really kind of say, all right, I think we're going to maybe go in a different direction with how we're going to use our money on these stormwater assets. There was a project that a Pittsburgh engineer I work with designed. They did phase 1, these nice rain gardens. Ton of trash got in them a year afterwards, and when they applied for phase 2, they didn't get the work because they were told there was too much trash in the systems they designed in phase 1, right? And that's a very hard thing to manage. That's a human element that you can't really take care of in your design. But they had a very specific idea of what they wanted these BMPs to look like, and how much maintenance was never ever meant to happen. What's interesting also, when we don't collaborate, we end up spending more money, which is kind of a little counterintuitive. When we think about collaborating, especially owners are like, oh man, more meetings, you know, and if I have 5 people in the room at $100 an hour, that's $500 an hour. Is this really necessary? Can we just move forward and get this done? No more meetings. You know, I used to always write proposals on a number of school projects I worked on, and we'd say, yeah, over the course of 3 years, we're probably going to need about 30 meetings. The architect would negotiate us down to 2 meetings, and then we'd end up doing 100, 70 of them on turf establishment at the end of the project. And no one really won. It was just sort of a good faith effort in the end. But we weren't budgeting up front for the collaboration that was needed to make those projects go well. When you don't collaborate, what I found is you end up needing to redesign critical project components. With that comes design fees and costs. So we now, at the back end, are spending that same money that we maybe could have avoided if we'd spent it up front. We see more change orders, and we see increased value of those change orders. And that again just comes down to poor communication, maybe at the front end, whether that's at pre-construction meetings, pre-bid meetings, or even on the design side. More RFIs, if the plans aren't clear, and we try to avoid having detailed plans with all the information we need, there's more RFIs. And for all you engineers out there, usually when RFIs come in or submittals are coming in, you've spent all your budget, and now you're trying to work out how to most efficiently get that done so you can kind of keep whole and move on to the next project. Sometimes you get more expensive lifecycle costs, and that's usually, again, just a communication thing with the owner and the engineer. They may not actually be more expensive lifecycle costs, but it might be perceived as more expensive lifecycle cost if they believe that, like many owners believe, that no BMPs ever need maintenance. But as I point out, your car needs maintenance, your marriage needs maintenance, and guess what? Stormwater BMPs need maintenance as well. You get more complaints maybe, so that's again just processing and administering and maybe making changes beyond the scope of the project. So with all that said, I mean, that sort of highlights a lot of the challenges out there when folks just don't sit down together and kind of do business at the table. So you might be asking, how does a guy who works for like ACF, a products company, fit into this mix? Well, we get a really unique perspective on the industry because we work with the engineers and the contractors. And so we have this kind of weird and unique position where we actually can kind of initiate collaboration between these parties, which seems kind of a little bizarre. But these days, with contractors spending less time working with engineers spending less time in the field, we're in a position where not only do we have a bunch of innovative solutions we help folks with, but we're working with the engineer during design, so we're helping them through that process, whether it's with our systems or even just, again, like that section before, coming up with the appropriate fabrics and liners and those types of things to use. But we also are out in the field with the contractor during installation. So we get to see a lot of things going on. And some have gone really well and some have gone poorly. And it's usually because the contractor and the engineer have never actually met and spoke. Plans went out, project got bid, engineer moved on to the next project, contractor bid the job based on their understanding of the plans and the detail that was there. And now we have a large gap that we have to overcome during or often post-installation. So our company chooses to collaborate during the entire process. The goal of that is to make the design plans buildable, so hopefully to help folks who are designing projects overcome some of these challenges in advance, but then also to support installation so those plans can be converted into reality. And so hopefully we can do our part in the field in making sure these things, or the contractor understands the intent of the design. And through that, we've actually helped minimize a bunch of unnecessary change orders on a series of projects just by being a middle player. It doesn't have to be us. It could be anyone. It could be you. It could be an owner's rep. But someone who's stepping up to the plate saying, look, I'm going to own this process. I'm going to own this collaboration, and let's make it happen. So we've been part of some great projects. I'm going to touch on those for a while. A couple of different categories. Up in Maine, that's where I did a lot of my consulting work, so I know a lot of players there. A lot of grant monies going into coastal Maine, southern Maine, coastal neighborhoods, and we've been helping folks through that process. On grant-funded projects, the parties are usually pretty similar to most projects, but you've got town staff, you've got the DEP, who are usually the ones administering the grant monies and making sure that the money's being spent appropriately. Environmental engineer, local watershed groups who are usually running point on the education component of these projects. Folks like us who get in to try to help solve the challenge, and often we'll get a call saying, hey, look, we've got $3,000 in this grant, we've got 11 acres of impervious we want to treat, and we have to obviously walk them back from that and realize you can probably only pick up maybe 500 feet of curb line with that $3,000 budget. But that's sort of a role we play in kind of tempering the budget and making sure the monies fit the goals. In these cases, Public Works is often the installer of the systems. It's a labor match as part of the grant project. So the grant pays for the materials. Public Works match that cost with labor and equipment. You got public, landowners, abutters. The specific challenges with these grant-funded projects are not the children on this screen, but often there's specific pollutants you're trying to go after. So a lot of the work I do in Maine is bacteria-focused, bacteria and stormwater near beach outfalls, but maybe it's metals, maybe it's phosphorus for lakes. It depends on where you are. But usually you're looking at targeting a specific pollutant that may not be your standard kind of pollutant array when it comes to site development projects and permitting. Finding candidate BMP locations. So these are all retrofits. Generally speaking, we're starting with looking on public land, so schools, public works facilities, municipal office facilities to deploy these, because that's the easiest kind of negotiate land agreements. But sometimes we need to go out and look at private parcels, and that's obviously a different negotiation with easements and who's responsible for maintenance long term and these types of things. Usually the money is so small that the money would all be spent in engineering design, so they're usually kind of done as a sort of more of a design build in the field. Generally small budgets, like I alluded to. And there's an educational outreach component too, so it's not all about just getting it done and putting it in the ground for the right price, but during the process, before, during, and then after installation, there's a specific component for educational outreach. So whether that's educational placards, whether that's teaching local the teachers in local schools as to how to take their class out to this BMP and know what they're looking at, and we get to be part of a lot of cool sessions with little people. It's fun. The way we work in these projects, we get out there and help with the windshield survey, so we try to identify candidate BMP locations. And for those who are doing this type of work, whether it's MS4 retrofit or any of these types of projects, there's nothing rocket sciencey about this. But when you're looking for locations for these BMPs, the goal often is to look for areas where you get a decent amount of sheet flow already going to a certain location where you can intercept that water and treat it. When you start getting into reshaping pavement and adjusting curb lines and doing a lot of peripheral work, or like adding storm drain lines to feed something to something, you end up spending a lot of your money just on the piece that doesn't interact with the actual water quality process. So this was a good example of taking about a 0.7 acre chunk of a high profile retail parcel right to one location, and all we did was convert a catch basin to a solid cover, open up the curb, and built a BMP right in that island that was designated there. Very little ancillary work needed for that. We develop sketchbooks, so and we do this at no cost, so folks have a general sense of, okay, what is this going to look like? What are the BMPs we're considering? What's the maintenance requirements? So there's good education on the front end. We talk about which of the specific pollutants they want to target, and come up with smart, hopefully high performance, space efficient, easy to maintain treatment trains. And you can learn about any of this stuff out at our booth later. Also, we get materials costs. So the first round of these projects we did, we came in late when monies were already assigned, and we had to kind of work out how we're going to fit a project to that money. Now we're a little more ahead of it, so early on in a project, we're part of that process now, and so as we're planning for different kind of BMPs, we're actually building a budget that gets put in when the grant money is assigned, so the appropriate monies are provided, and we're doing much better BMPs today than we were 2 years ago when we were kind of coming out of that hole. So that's that. In the field, on these types of projects, from our end, we're procuring materials, delivering them to the site, and we're supporting and coaching the Public Works crew. And generally, we're empowering the local crews to do that. And sometimes, if they're too busy, we bring in site contractors to do the work too. And then our goal is to support education outreach. We don't make any money from doing this at all, but our goal is to sort of, in the name of collaboration and water quality, get out there and help folks with that initiative. And usually, you need someone to kind of help, and this is the encouragement to you. Each of you here can be the driver and the encourager of moving some of these elements forward, maybe outside of your typical scope, but I think that can make you unique as a professional and maybe for your company as well. Then we do post-installation maintenance, stuff like that. In Maine, last year I worked with a whole bunch of different towns, just going around, finding out what the pollutant of concern was, looking for candidate BMP locations, and installing systems. A couple of those systems, this is the one that I showed you on that windshield survey. So this was a high-profile retail. It's actually the Kittery trading post just across the New Hampshire line into Maine. Some of you may have visited there before. Like I mentioned, we found a nice 0.7 acre piece of trib area, went to this corner. We opened up the curb, converted a catch basin into a solid cover, put in a little pre-treatment unit, dug this 3-foot, this is a high-flow biofilter, it's called the Focal Point. I'm not going to get into that right now, but it's basically a space-efficient rain garden, high-flow media. We built it up in layers with Public Works. You can see Public Works was out there because there's a good amount of riprap there. The landscape architect in the room, that tree was actually dead before we started, so that was removed and needed to be removed anyway. But this system is very stable. It's not floating anywhere, going anywhere. And what was cool here is we actually collaborated with the owner, because this was on private land, and we said, hey, this is the plants we're thinking about using. And they're like, whoa, 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 time out. We have our own landscape architect, our own landscape designer, and seasonally we do different kinds of things. We'd like this rain garden to fit in with our general planting scheme. And it was really cool. They picked the plants, they installed them, and they've taken over the ownership in terms of maintaining those too. So kind of a neat little space-efficient BMP, no parking loss. Great water quality treatment in that little neck of the woods. This was Ogunquit River Beach, or Ogunquit Beach, which is the Ogunquit River feeds. This was an impervious parking lot, fully paved. They make money on this in the summer. It's like $20 a day to park there. So the idea of losing parking spaces is a no-no for the town there. And generally speaking, green infrastructure isn't considered an option in these types of environments. We think, oh, we got to go subsurface. We got to put in some concrete vault and do something like that. But green infrastructure has a really good history of treating for bacteria. We've done our own testing on our system, but just in general, the bioretention, that plant process, all the different things that are happening in that soil, chemical, biological, and the like, really good for spearing and trapping bacteria. So these were put in there to basically collect water from that parking lot right there and treat and then release the water to a beach outfall just downstream, which had been closed and deemed non-swimmable for a portion of last year. What's interesting in these grant-funded projects is that collaboration is alive and well. And I think maybe on some of those more local, sort of more intimate projects, it's more realistic often for these to be part of the process, or it's sort of anticipated because you just have a lot of parties who want to be heard. So, all parties strategically choosing to cooperate in order to achieve shared or overlapping goals. What's interesting in these projects is that not everybody has the same goal, right? So the contractor doesn't really care a whole lot about why we're doing it and why it's happening, but the Public Works want to get that built and get out of there as quickly as possible so they can get back to other work. The watershed groups are not too concerned about what the BMP is, but they're more excited about the fact that they're using this grant money and they can now educate folks about the importance of treating and water quality. On our end, obviously, we're essentially getting paid for those materials, but we're also helping select a specific kind of BMP to treat a specific kind of pollutant. So everybody has different goals, but at the end, there's this overlapping general idea of, okay, we're working together, we're linking arms, and we're trying to improve water quality in this particular impaired stream. So not same goals, but there's some overlapping goals and overlapping objectives there. On the site development project side, there's different kinds of challenges, the different parties maybe. So in this case now we have a client and an owner, a design team, maybe civil engineer, landscape architect, and other parties, review agencies, folks like us again, contractor, inspectors and oversight. And then you've got specific challenges. So in the case of these projects, obtaining permits, that's a big problem, right? So you've got to come up with a scheme that's going to allow you to achieve all the regulatory requirements, whether that's stormwater, that's erosion, whatever it may be. Managing project costs, big one here, right? And not just the cost of the project as your scope starts to creep, but the soft cost too. And that's where collaboration comes in. And that's going to bump up your soft costs a little bit, I'd say, on the front end if you're choosing to meet and go through some of this stuff early on. There's always a financing component, so who's going to fund the project so it can actually get built. And these are all these pieces of playing kind of are not mutually exclusive, they're working together. You need detailed and buildable plans, like I mentioned earlier, and this is something we've got to keep pushing for as civil engineers and landscape architects, not going to the street with these 25, 50% drawings, which don't allow the contractor to fully understand what's going on. Either you get low cost because there's not enough detail, or you get really high cost because contractors are like, I don't know what is on these plans, so I'm going to double my price, you know? And fair enough, if you don't have the information, you don't want to be at risk to losing money when the project actually goes forward. Good specs, right? We talked about that a little earlier, making sure that we're thinking through each of these components. Even if some other person in our office has designed a system a certain way for the last decade, we've got to take ownership of that as the stamping engineer or the authorizer of those plans. We've got construction challenges. We sort of talked about those earlier. On the site development projects, our process looks pretty similar. So we support the engineer during computations, sizing, concepts, all that kind of stuff. And what I'd say for all the vendors that are out here today, seek to engage them in this process. Whether you're working with my company or any of the others out there, there's a lot of great vendors with a lot of great solutions out there. But they can be very valuable to your process just in making sure, just checks and balances, making sure that this system that you're using that's theirs, has been designed in accordance with their specs, has been sized the right way, and those types of things. It's a good check. It also allows these companies to speak into just the logistics of the project. So, what's the lead time on these systems? Maybe what a good budget cost is for these systems. And in some cases, they may find that, this actually isn't probably the right application for this system. Maybe you want to look at this other system. So bring them into the process. And certain counties and states that I work in now actually require folks like us to write a letter before the permit documents are submitted saying, essentially as the manufacturer or as the product representative, we've reviewed the plans and have deemed them to be, in line with our specifications and product limitations, whatever it may be. So that we're seeing that happen more and more out there in the field. Layouts and details, most companies now like us will prepare a lot of layouts and custom details for you to support your project and make your time as efficient as possible. Looking at custom solutions sometimes, and like I mentioned there before, happy to review the plans and details. And our goal when I review the plans and details is to make it not just a permittable plan, but to speak into the constructability of the plan too, and the logistics of different trades and other things that are going to be coming through this site during the course of the project. Other good thing is we can provide really good budget costs. So not only the materials cost, but also a pretty good sense of installed cost based on previous projects. So we do that kind of work. In the field, we provide material procurement. We have our own pre-construction protocols to make sure everyone understands how these systems go together. And we support the site contractor. And when you're looking to work with any kind of innovative company, make sure they have construction oversight as part of their services. That's a really important part because when you're out in the field as the engineer, maybe you haven't seen these systems go in a whole lot before, So it's good to have someone out in the field, sort of a tech or a representative from these companies, just to make sure things are moving along the way that you think they are. Okay, a couple little projects here. This is a great concept when we talked about, or a great example of when we talked about different kind of geotextiles earlier. So this was an infill housing development project. They demoed a little individual single-family home and somehow built 44 housing units on the lot. It's like a postage stamp lot, but that's the way of the world, it seems, these days. What's interesting is from the face of building all the way out to the edge of our subsurface system, our R-tank, there were 5 different fabrics used, 5 different materials used to make sure the system would perform correctly. So when I first got this plan from the engineer, they just had a line that said geotextile, kind of wrapping the irregular shape of this section. In the end, roof runoff comes off the roof, obviously, hits this riprap spillway, or this little splash pad. Now originally we were talking about using a liner around that riprap apron. However, the liner would prevent water from eventually draining out of there, so you might have a mosquito issue at some point. But we also didn't want it to drain too fast because there was a foundation drain in the little corner here, so we didn't want it to short circuit and go straight down to the foundation drain as opposed to going through the treatment process. So we used a much heavier fabric, like a 500X, underneath that riprap so that it would drain slowly but wouldn't be free draining, but also wouldn't pond over time. Water came through that spillway, stepped up over onto this biofilter. This is another one of our focal points. Filtered down through. Now we transitioned to a non-woven fabric as we came out of that riprap area. There was a microgrid and a woven monofilament through our biofilter section. And then we used a little curtain of liner on one edge to prevent the ability of water to kind of seep out the side. So a lot of different materials in there. And again, if we just said geotextile everywhere, the system would not have functioned the way that we would have wanted it to function. So important to think through those things. And this one has a little biofilter with expanded storage. This was built as a 3x11 sort of box, essentially, but luckily we had a great landscape architect on this project, and at the surface they kind of made it more interesting. So a little wiggle, a little berming, a little interesting. So it looks like a rain garden from a distance, but it's really a high performance, high flow media system. And a year after this system was put in, this is green infrastructure at its best. The building's actually green as well. I thought that was temporary for a number of months, and I was like, wait, you guys are rolling off site. What's going on with the color of the building? But they somehow convinced the city of Portland, Maine, that was in line with the local architecture. So that's that. Right in the corner you'll see this little rain garden. That's where our biofilter is. And then there's expanded storage underneath all of that concrete patio area. So we got the 44 housing units in this very tight space. We got the treatment done. We got infiltration done, or loading ratio done. We got channel protection and flood control done, all in that space. And there was still that concrete patio area above the subsurface tanks for the enjoyment of those tenants. This is another little interesting project in Massachusetts. This was a rock climbing gym that was adding a parking lot. This was an existing parking lot up top. I guess my laser is struggling, but lower, a new parking lot here. And they had the challenge of wanting to basically fill the entire area with parking, like all of us do as civil engineers, pave paradise, put up a parking lot. We actually were able to get water quality treatment done all within the space of a regular landscape island here with one of our biofilters, but we still had to satisfy a volume piece for infiltration and flood control, so we expanded our box under drain back underneath the parking lot. This is a very common approach in PA, where you usually bioretention fills up all that land, but with these high flow media systems you can have a space efficient green infrastructure system drop down and then still achieve loading ratio back underneath parking with HS25 modules. So this was it being built up. You can see the tanks going in and then the system being built up. This was very limited vertically, so this whole system from surface of mulch to underside of those modules was about 2.5 feet, very tight with regard to groundwater, but still being able to get infiltration done. And here was a finished product, and this is a great little retrofit here that took a lot of coordination with, again, the geotextiles and making sure water was getting to the right place, getting filtered and getting handled post-treatment for infiltration. This is another nifty little example of collaboration and coordination. This was actually the same engineer and landscape architect that worked on that infill housing one I showed a minute ago. This is another infill housing, but right next to an impaired stream. And we had a very sort of unusual shaped area available for doing stormwater storage. So we used these modules, these R-tank modules, to create a nice little chunk of storage in this kind of arc-shaped area behind a big block retaining wall. The wall was lined so it couldn't seep through. But this all had to be done in a very space-efficient area. There wasn't room for wet ponds, bioretention, all those types of things. So this one actually had a sand filter put over the top of those tanks, and then it was finished off with an open joint permeable paver. And you may have seen this project. This was actually in Stormwater Magazine back in May. But this was, as you can see, again, tight site, building and parking is basically the entire footprint of the parcel. The building directly discharged to the tanks, which are under those pavers. And then the rest of the site sheet flows over to those pavers, goes down through that sand filter, and is collected in the tanks for controlled release below. So kind of a nifty little application, but a lot of coordination here, right? So when you're dealing with permeable pavers, most of them are concrete. In Maine, as you know, we get a lot of ice and snow, and people love to just douse salt on everything. Food, pavement, the whole works, right? And salt and concrete don't really get along too well, right? So it was important that at the front end, when this engineer was thinking about using a permeable paver, that we all sat down with the owner and said, okay, this is the BMP we're looking at, but these are the implications on maintenance. We want to use a rubber tip blade. We want to use light sanding and light salting as opposed to really heavy salting, because over time that'll start to pit that surface, right? So that was an important thing to have, as opposed to coming back a few years later and an owner saying, well, what's going on with these pavers? They're falling apart. Well, what are you doing for maintenance, you know? So important to have that conversation. And that's become way more of my dialogue early on when I'm working with consultants now, is having a realistic conversation. Okay, yes, this will fit here, or yes, this will achieve your goals, but what does the owner think about having this particular BMP on their site? How is that going to work with their long-term cost of ownership? In Baltimore, another little project to touch on. I'm working on a project called the Hendler Creamery. It's a redevelopment project of an old brick building downtown Baltimore. Parties here. Really interesting group called the Design Collective. I don't know if any of you have worked with them before, but they have landscape architecture in-house. They have architecture in-house. They have mechanical plumbing. They have structural in-house, and the only group they didn't have in-house was civil engineering. So they worked with KCW, who some of you may have heard of before. And what was really cool about this project is that we came in early in the project. So right at the beginning of the project, it was like a kickoff meeting, and everyone said, all right, look, stormwater is going to be really tough on this project, and we'd worked with KCW before, so they brought us into the mix. And how are we going to solve this challenge? Well, what were those challenges? City site, fully built, it's all building, there's no other space but building and the city sidewalk. And this building had a few interesting challenges. Shallow existing utility connections in the street. But also this redevelopment project was basically going to have a raised deck. So it was going to be parking underneath and a raised deck. So all the stormwater actually had to be at least one level above grade, which is kind of different. So not only were they looking to treat the stormwater, they're also looking to make this a very high-end sort of raised deck area with pavers and benches and a really nice aesthetic for their tenants in this new residential wing. So they need to use green roof media for the trees that they want to plant, lightweight but suitable material for those trees. However, that green roof media isn't approved as a stormwater quality treatment BMP, right? So we needed to use the stormwater media, which in the case of this project was our focal point system again, to handle the stormwater. But the challenge then is how do you direct droplets of water to the right place, right? How do you split the water up so you get treatment before you spill over and provide water to the green roof areas? And then there were structural components that had to be factored in. So this is one of the only projects where the structure of the building was kind of working in sync with the stormwater, right? We were kind of playing around, if we do this to the balconies, if we do this to the deck, or if we bring the roof drain here, how can we fit everything in and get our permit for both the building components but also the stormwater piece. So these images won't show a whole lot, but like I said, we all sat down and it was this mix of these 4 parties that had to nut this thing out. And in the end, you'll actually see the areas where there are trees, that's where the green roof media is, and we don't typically put trees in our high flow media, they just don't typically do very well. But in the lower shrub areas, so those rectangles at the end, that's where our stormwater quality areas were. You'll see here there's these kind of little partition walls between the different balconies that takes water from the roof, spills it out into this trench. This trench takes it and it feeds these water quality areas. And then once they're maxed out, it actually spills over and backfills into the green roof areas for higher or larger storm events. Looks kind of simple in concept. You can see that here too. But the challenge, obviously, of splitting that up, getting water to where we needed it to go, and then also still maintaining the aesthetic that they wanted for their tenants was a particularly difficult task. So that one was a bit of a doozy. Collaboration construction. A couple of thoughts on this end. I think this is one of the biggest pieces where we can do something when it comes to collaboration for very low cost. And what we can add this to our kind of scope of work. So something to think about, getting contractors involved early during the design process, whether that's having to pay them for that time, knowing that they may not actually get the project when it goes to bid. Getting them involved, thinking through these challenges. They've just built 10 sites recently, maybe with a similar BMP, and maybe there were things that made them pull their hair out, and there were other things that they had successes on. So that voice is a very important part as you're thinking about the next project. Maybe that's local conditions with karst soils or clay or high groundwater table or bedrock or whatever your local challenge might be. We should consider building construction oversight into the specs by a qualified party. 10 years ago, this was standard, right? As the engineer of record, you would go out in the field and you essentially certify the installation. We've got to bring that back. So whether that's the engineer of record, a third-party inspector, or even a product representative. And I throw this on the board because we often have engineers, working with maybe one of our systems for the first or second time, and they maybe don't have a lot of experience with the actual construction sequence of these systems. They know what the finished product needs to be and maybe how much water it needs to hold or what kind of treatment volume it needs to produce, but maybe out in the field, they're not maybe the right person to be out there, or maybe they're the right person to have out there with someone from the product company. And that's why I said earlier, make sure when you're working with these products that they have built into their sort of service involvement during construction, so you can pair up with them and hopefully learn something, so the next time around you can say, boom, I've seen this before, I know exactly what I'm looking at, and now that can be part of my services as a civil engineer. Pre-bid meetings. If you only walk away with one thing today, Pre-bid meetings. Sometimes we have projects off on a larger scale, government jobs, school jobs, these types of things, where they have mandatory pre-bids, right? So every contractor has to go there. But what is the information we want to convey at the pre-bid? Not just, okay, here are the terms of the contract, here's the project, here's the day your bids are due, this is how the project will be awarded, et cetera, et cetera. But on these green infrastructure BMPs, as the landscape architect or the civil engineer, hopping up, taking the microphone for a few minutes and explaining, okay, this isn't your average rain garden, The media that I've specified in this system is not something you can make with a few buckets of this and a bucket of that in your backyard. This is a specialty media that you either need to source from somewhere or you need to make a certain way. There's certain testing requirements, because the challenge we see when these pre-bid meetings don't happen, we get a lot of differences in the bids that come in. We get some folks that maybe have done some of these systems before with you as the engineer, and they understand, okay, yeah, this isn't just that system. I've got to spend, it's a premium for me to get the right mulch for the right media, all those types of things. And then others might be new to it and end up putting in a very low bid because they're unaware of what those specifics are being. And that's no fault of theirs often, because again, going back to my earlier slides, we don't do the best job as engineers specifying these individual components. So pre-bids are a really good opportunity to get everyone on the same playing field, understanding the components and the importance of the different pieces, even understanding what the aesthetic needs to be, caution around the plants, speaking into natives versus invasives, spacings, all those different things, so we're not just putting $200 aside for plantings and throwing in whatever the local nursery has at the time. Choosing to work with a contractor, engineers. I mean, I was speaking with a site contractor about 18 months ago who had a media for a rain garden rejected 15 times. No comments, just like rejected, rejected, rejected. And as civil engineers, we love that rejection stamp. We love to just play that once in a while. Like, nope, that's not what I want. I'm not going to tell you what I want, but it's not what I want. Let's get over ourselves a little bit, right? Let's try to work with them and come up with a reasonable outcome, right? So maybe they've learned something from a previous job, or they understand the different sources they have, and maybe they found that maybe the media we're specifying has had some challenges in the last job. Maybe that's the media that the finger was pointed at them at last time, saying, hey, why is this thing clogged, 3 or 4 days after a storm event? So let's just be open to hearing what the contractor has to say and taking that feedback and seeing what we can do with that. Then obviously pre-construction meetings. So now you have a low bidder in place who has adequately catered for all the components of the job. Obviously good to sit down and say, okay, now we're working with you guys. What are the key components that we need to think about moving forward? What are the logistics? When do we want to put plants in? When do we want to put the media in? Do we want to put the media in early? But if we're going to do that, how are we going to protect that from other construction debris, silt, sediments? All those just sort of practical things to make sure we don't compromise the system from the get-go. Last little topic here, urban green infrastructure successes. So on the larger scale, or on the more national scale, City of Philadelphia, you've probably heard of their Green Streets program. Some of you I know have been involved in that program in the past. I work in a lot of areas, like I mentioned earlier, so I get to see a lot of different things cities are doing. And Philadelphia is one of the cities I find to be doing the most impressive effort as it relates to exploring what it looks like to green a city. So my role in that space is I just work with dozens of engineers who are trying to overcome your standard kind of challenges with urban retrofit, space, performance, pre-treatment, these types of things. Green Cities, Clean Waters, you've probably heard of this. There's a design manual. You can find a lot of this great stuff online, some great ideas, some great graphics, some great BMPs that they've thrown out there. The goal there is to maintain or manage 10,000 acres of impervious over 25 years. Pretty good chunk of area. And in that is about 2,500 miles of streets to green. And they're plugging away at it. Every few weeks there's a new project on the street. We provide a lot of materials into this program. Great quote here from Howard Newcraig, who used to be the commissioner there a couple of years back. And this lines up very nicely with our concept of collaboration. So he says the key to the success of green streets is to develop a seamless process whereby stormwater management, street engineering, landscape design, come together to produce a functional, attractive, and cost-efficient project. This manual provides a toolkit for city agencies, contractors, and private partners to achieve that goal. It's a pretty cool statement. That brings a lot of the key players into the mix as part of the goals for this project. And if that motto or that mission statement is being carried out, collaboration is alive and well. So what's unique about Philly? I think a couple of things. They've got a variety of green infrastructure options, which is really unique. If you go up to New York City, there's kind of the standard right-of-way bioswales that are rolled out, which is simple from the design side, but you kind of lose some of the flexibility that you have in the city of Philadelphia. They allow for innovative solutions, so that's nifty. So if you get into a spot where the traditional doesn't work, they can transition over to innovative solutions. We find most of the work we do down there is in pre-treatment and screening, and also in modular storage. So they usually use like stone at 40% voids for their storage pits on the street. And if they can't get enough storage out of that, they bump up to like a high void space module like our tank or the storm tank that you'll see at a different booth out there. They also not only understand the capital cost, but the long-term cost of ownership. So they've invested tons of money and have tons of staff working on the long-term maintenance, right? And not just conducting the maintenance, but studying the variables of maintenance, weighing sediment, measuring and timing frequency, efficiency of how long it takes to clean this or that. And because of that, I think they will genuinely become a green city as opposed to a very weedy looking city that people regret ever doing what they thought they were going to do. How does that all get achieved? Collaboration of a lot of parties. So there's the city officials, you got Philadelphia Water Department who administer that program, great team of people, all kinds of different departments, maintenance, design, plan review, working with private consultants and doing in-house work. Engineers, a couple of dozen engineers out there, landscape architects, yay, and there's a huge outreach and education part. So it's very much part of the community, people understand what's going on and what they should be looking out for there. And there's also long-term maintenance and monitoring, like I mentioned. And to touch on the whole piece, I think the thing that makes it most unique, and this is something I've really just come across really in the last 4 or 5 months, is that maintenance is driving design. Simple concept, not something that happens a lot out there. Most of the projects we work on, folks hope that, like I mentioned earlier, that these systems don't need any maintenance. I get calls all the time, like I want to handle bacteria, metals, hydrocarbons, and phosphorus, but it needs to be zero maintenance. That's important for my client. I'm like, oh boy, you know, I think you called the wrong number. But in Philadelphia, maintenance is driving design. Maintenance has a voice at the table, so when folks are looking at how they can improve details and specs, maintenance at the table. And it's not just the director of maintenance, it's actually folks who do the maintenance in the field, right? They're at the table and they're saying, look, and I'll show you an example in a minute, when we go clean out this kind of filter, we dump 80% of the sediment back into the drain. That just doesn't seem right, you know? And without that voice, no changes will be made, and we continue to dump and do all this counterintuitive work out in the field. So here's a great example. So there's a filter insert they've been putting in their green city inlet, and we call it the Type P, for a number of years. And this inlet, this little insert is a long, 4-foot long bag, filter bag. They call it a green filter or green inlet. And basically as water comes in off the curb, it collects sediment and debris, right? Fine. Now the challenge is when they go out to maintain these, they're generally not using a ton of equipment. So either someone's lying in the street with their legs out into the street, which is obviously a somewhat dangerous event, and kind of reaching into this fairly narrow hole to sort of hand scoop that sediment out, or they grab that 4-foot unit and they bring it out of the drain. The challenge is that drain only has a 24-inch diameter manhole cover. So when you take that 4-foot long kind of trough bag and tip it up to get it through there, most of the sediment falls back into the drain, right? And this has been happening for a long time. And without maintenance, that would have never, without that voice of maintenance in this collaborative process, you know, we just continue doing the same thing and wonder why we're not getting a different result. So we actually worked with the Philadelphia Water Department since about a year ago to develop something that would overcome these challenges. So I'm going to touch on that, really with the emphasis on the importance of that voice in maintenance. So we needed to come up with something, we had to have something that would be easy to install, easy to maintain, and we had to improve the performance and durability because the system they were putting in kept collapsing and falling into the drain beyond just the maintenance issue. So we started working on a product to try to overcome these challenges. The goal was to minimize the danger or the concerns for safety during maintenance, and also to minimize the escape of sediment into those drains. So we thought, hey, look, if we can come up with a circular bag that fits under that 24-inch diameter manhole cover, that should be good, because then you can actually like clean it in place, or you can pull the bag out, right? Good idea. And that's basically where we landed on the bag design. But so we made this first prototype, got out in the field, got 30-odd people together, and we're ready to like flex our muscles and show how cool we were. And then we realized that the opening we were trying to slide this unit into was only about 2 inches high, and our unit was about 8 inches tall. So it was a very quick end of meeting. Sorry for wasting everybody's time. We'll be back. So we worked collaboratively with the Philadelphia Water Department. So R&D from a product company working with that department, a bunch of markups, a bunch of red lines, bunch of testing, but we found the key thing here was to make sure this entire unit could fit into an opening that may only be 1.5 inches tall, right? Kind of challenging. So So we went through a bunch of R&D, tried out different metals, different sheets, different thicknesses, different types of attachment. And in the end, this is the sort of finished product. We finished with this, what we call the Green City filter. This is what Philadelphia Water Department are using exclusively now on their Green City inlet. So we have the circular bag, so that's taken care of. The bag is three-part. There's a mesh on the inside and a mesh on the outside, and then a woven monofilament halfway up the bag. The mesh on the inside protects the bag when you're trying to clean it in place. The mesh on the outside protects it when they pull it out of the drain and generally drag it across the sidewalk to dump it out. All of these components fit in a 1.5 inch opening. So there's that flat panel, or that pan, that's about 2 by 4. That's one piece that can slide in. And then there's 2 side supports that all fold up to 1.5 inches. So it's 2 sides, a center pan, and a bag. Bag can fit up through that manhole or be maintained in place with no loss of sediment and no legs out into the street. The only criteria, or the only thing that goes in the drain is a person. There is a waist size denoted in the spec. And then the bag goes in after the fact too. What was interesting is we had this all set as sort of a fixed unit, and then when we got out in the field, we realized that not all these drains are the same, right? Every single one's a little different, so we need to incorporate some adjustability. Now, some of them have this kind of ledge on the inside where the upper portion of the drain is offset from the lower portion, so we added this dovetail flange system, this sliding system here, to be able to essentially work with that ledge and be able to slide that unit so the front edge of that pan is always right up against the entryway into these drains. Kind of cool. Solved a lot of the challenges. And so the product is less important than the process here, as cool as that is for that application. And if you work in a municipality that has specific drains that need some help, we can certainly help build custom stuff for you. But the cool thing here was that this would have never come up if if maintenance didn't have a seat at the table. And it was so encouraging, even when we did our final product release with them a couple of months back, they had everyone in the room. They had design, they had plan review, they had the heads of departments, but they also had folks who were actually doing the maintenance. So cool, so simple, but so cool. Last thing I'll touch on in my final minute and a half is a little retrofit project I'm supporting in Reston, Virginia. Many of you are probably familiar with the ASCE organization. They're actually headquartered in Reston, Virginia. This is an aerial shot of their parking lot. So large building, big office building, and a parking lot on both the east side and the west side of the building. I'm going to say about a year ago, they were looking to repave their lot because their parking lot started getting a little bit cracked up. And I was kind of out there recently. I was like, man, you should see pavement in Maine. This is like totally fine. You don't have to do anything. But they're still moving forward. So they're looking to do an overlay. And fortunately, the sustainability group came in and said, whoa, 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 time out. Like, we've got to walk the walk and talk the talk and walk the walk. We have to be leaders here. If we're going to repave our parking lot, we need to look at what it would cost to retrofit our parking lot with low impact development green infrastructure techniques. So they brought a team together, which fortunately I was able to be part of. So it had ASCE staff, regional experts, county officials, so it's in Fairfax, Virginia, so they had Fairfax folk as part of that because we have to understand what are the permitting implications, even if this is just sort of being done out of goodwill. Engineers, so local engineers who have worked in that area before, from the survey side, from the geotech side, and from the design side. Some solution providers, so folks, I was there was a representative from Contech and a few other companies, knowing that, they were going to be looking for participation and donation of materials and those types of things to make this thing happen, but also to get some specific experience or expertise in some specific types of BMPs. So we worked together to prepare a preliminary plan and a progress report that was presented to their board, and it looked something like this. We got the go-ahead in late July to kind of move forward. So the blue area is really designated as future home of permeable pavers. So this allows over time for different permeable paving or paver companies, whether it's porous asphalt, concrete, ICPI pavers, the pavers we work with, whatever it may be, to come in and kind of pick off areas. And then the green areas represent opportunities for green infrastructure BMPs. So there's sort of a feature BMP on both sides, and then there's a couple of, I guess you call them MTDs or innovative technologies that are put in there too. So it's sort of meant to be a bit of a showcase, show off different types of technologies, different types of things, and also allow both local consultants to either contribute time or monies to this program. In the case of product companies, obviously hopefully donate or provide materials at a reduced rate. Because the budget really was for the paving and a little bit more for the green infrastructure, kind of like a lot of projects, right? But if you look at the amount of space these BMPs take up, if you take out all those green and blue areas, that's a lot less area to repave, right? So it actually reduces the scope of pavement, which is kind of interesting. And interestingly enough, this will be built in phases, so the permeable pavers won't all happen, but we're making sure to not repave those blue areas now, because we know within the next 2 or 3 years, those are going to be cut out and permeable pavers will be placed. So it's smart, again, to think about this up front, so we don't go out and pay the whole lot, and then in a year's time, cut out brand new pavement. So we're finalizing the budget, always looking for additional sponsors and contributors to that. If that's something that spikes any interest, you can chat to me about it. Our focus there is water quality treatment, although in Fairfax County, channel protection is a big part of the design too. So voluntarily, we're considering channel protection. That will all come down to budget, because that'll end up being subsurface chambers, whether that's the Arch Storm Tech or R-Tank or Storm Tank or any of the systems that that Contech have as well, large pipe, those types of things. So that's being considered as an optional add-on. Post-construction monitoring is being considered, and originally they had this great plan, hey, we want to test for water quality, we want to test for this and this and this, and for those like me who have worked through the process of testing systems, it's very expensive, and to test those systems would cost more than the project budget, actually. So we're going to focus the testing more on temperature, flow rates, we got rain gauges already set up out on site, so simple, more visual things that folks who visit this site, because I'll be doing tours, and this will be a big part of their, they'll promote this, I'm sure, across the country, and they want to have some of that component in there. And if things go well, construction will commence later this year. I've got a meeting in a couple of weeks to get an update on that. And that's currently what the plan looks like. So different types and prioritization of permeable surfaces around the perimeter. And then sort of a suite of different kinds of green infrastructure BMPs, from structural soil or those like silver cell type BMPs in a couple of select little tree islands. High flow biofiltration, which will hopefully be my system in that first BMP there they put in, and then there's some other on the back too, a Contech unit, Filtera unit down the side, a few things like that. So that's where that's at. But in conclusion, a couple things to think about, and hopefully this will resonate with you as you leave. My belief is that collaboration is critical to successful projects. Collaboration can look a lot of different, look differently to different situations, different types of projects, different players, but it doesn't happen by accident. So you must choose, like we said in our definition, you got to choose to be the collaborator, because I think as humans we just generally sit back and wait for someone else to kind of take that role, because we know it's going to take time, it's going to take effort, and maybe we're not really feeling too excited about that and want to be a little more lazy. But if we sit back and wonder why collaboration isn't happening, it's never going to happen. We need to take on that initiative and be collaborators. So collaborate, and just to finalize on that, or to finish up on that definition, collaborate, a purposeful relationship in which all parties strategically choose to cooperate in order to achieve shared or overlapping objectives. So just think about how you can collaborate in your projects, in your community, and the different ways that you can inspire folks to link arms, work together. It sounds a little bit cheesy, but I'm confident that you're going to get a better project at the end, and I would debate that collaboration is going to cost you more money than a project without any collaboration. So hopefully that was interesting for you this morning, and we can take questions. And I think if you're asking a question, there's a microphone that'll float around, so just raise your hand and we'll pass it on. Another thing that came up yesterday, one of the vendors that were here made a great comment about working with your local nurseries as well, so on the planting side of things. And I laugh at ourselves a little bit in this context. You know, with our biofilter, we have a plant list that is used nationwide, right? So technically, if you're in Florida designing a focal point, and you're in Maine designing a focal point, you got the same plants to choose from. It's a pretty good deal, right? But we all know that things are a little different, especially at this time of year between Florida and Maine. So while there's often guidance on types of plants, you want to be looking, obviously for native plants, but you also want to be validating any list or anything that you're looking at doing with local nurseries. Sometimes that's just based on availability and the different kind of options they may have. But they may also have some specific experience saying, you know what, hey, I know you want to use black-eyed Susans over there, but we found in this particular area, these haven't done as well, and you might want to look at something else instead. They may also be able to speak into the type of soil media that you're planting things in. So whether you're a civil engineer or a landscape architect or a contractor, that's an important part of the collaboration more at the construction end to make sure these plants are not only available, but are suitable for your kind of planting region as they kind of divide it up from top to bottom. I just asked myself a question and answered it. Any other questions out there? Yesterday we had 4, so the goal would be to break that record. Here we go. We got a microphone over this way.
Now I can talk about it.
Okay.
On some of the rain gardens where these BMPs that you showed very, in a lot of detail with the geofabrics and whatnot, are you seeing them needing to be replaced after a certain period of time? I realize they need to be maintained, but after you put all the stormwater in for 3, 4, 5 years, I've seen them start to clog and start to not function as well as they did within the first year or 2 after installation.
Yeah, good question. So to repeat the question, and I think I'm going to repeat this right, is are we finding that there's a certain point in time after rain garden's been installed that it needs to be replaced or significant improvement needs to be made, right? Whether we're noticing it clog or whether we're, I mean, that's probably one of the bigger kind of telltales, right? If it's got water sitting in it. So there's a lot of elements to that, and everyone probably has different perspectives. So if you put in a rain garden and do no maintenance, and then a few years later wondering why it's ponding, it's probably because none of that sort of regular maintenance was done. So for example, in the biofilter that we work with, our focal point, we require roughly once a year pulling off the mulch and putting new mulch back. And the reason for that is a lot of the sand and grit that comes off the road gets bound up in that mulch. So you take off the mulch, which you rake off all that sediment debris with it, put new mulch back to protect that media. A lot of these green infrastructure systems, because you have the plant element of the uptake of the nutrients, there's no need to necessarily, from a water quality standpoint, replace that media in a specific 5 to 6 year period, but that maintenance over time will start to spoil the top of it. So assuming that you put it in correctly and it's the right media and it's performing fine, there's no, I think the challenge is most people don't maintain them. So when you get to the kind of oh crap moment, this thing is ponding 3 months after it last rained, it's sometimes a little late and you do have to dig it out. But if you keep up with regular maintenance, keep in there, get trash out of there, get any sediment load out of there, there isn't any specific, I think, identified replacement period for a lot of those systems. I think that from the DP standpoint, you put it in and that's a one and done thing. It's not in 10 years time you have to dig it out and redo it. But a lot of that comes down to quality control. If you have a good spec and it's installed correctly and it's draining well, then you should be off to a pretty good start. Then you think about pre-treatment. So I'm a big fan of upstream pre-treatment and screening, whether it's required or not. So how can we protect that green infrastructure BMP from receiving that sediment load? So whether that's putting in some kind of catch basin insert, or we have a couple little curb line precast systems that have a screen in it, protects the system. It doesn't completely smash the plants. Couple of thoughts. Another thing to look at is if plants are alive or not. If you go out to a green infrastructure system, 2 things to tell if it's not working right is they're ponding, multiple days after a rain event, and are the plants dead, right? If the plants are dead, then we're not getting the water quality treatment that we think we're getting. So maybe we replant them, see how different set of plant will do. Yeah, I think the biggest challenge with all that is that maintenance doesn't get done. And then we're surprised why these things are clogging.
Did you have any suggestions on how to deal with either floating or moving mulch?
Great question. So when we work with systems, we use a hardwood mulch, so it's less susceptible to floating, but obviously that's never foolproof, right? So you get a certain kind of rain bomb or intense rain event you can't control where some of that mulch goes. So a couple of different schools of thought. So we generally suggest folks doing some kind of delineating perimeter with like a river stone or something, whatnot, to actually kind of help that creep of that mulch so you don't end up with it all throughout, maybe your grass bowl around it. We often get questions about, hey, can we just use like river stone on top of this media instead of mulch? The challenge from a maintenance standpoint with river stone is that all the sediment goes down through the stone and gets straight to the media as opposed to the mulch, but kind of binds up the sediment. You can kind of rake it off fairly easily. So there's a few different competing interests. I've seen folks use like a mesh over the top before, like a simple netting over the top to try to hold it in place. But I think a hardwood mulch is definitely the way to go. A little bit harder to find than softwood mulches, and something that doesn't have a ton of fines, so it's not going to kind of form one big blanket and kind of lift and float around. It'll be larger kind of shredded particles. We saw one team do the river stone, but then there's the ability to like kind of lacquer it. Have you guys seen that before? Like spray it with, and it looks really cool and shiny, but like the rainwater doesn't get through it anymore. Hi.
Hi. clients that come to you, I'm sure from Maine to Maryland, you've come across the issue with TDS with road salt. I know it's a big issue in this area, and I don't know if there's a certain type of treatment you could do before discharging or so.
From the road salts? So the question was on what kind of options are there out there for handling essentially the chlorides, right, when it comes to road salts and whatnot. Yeah, there's not a lot out there. So I get calls often like, hey, we just need a simple filter to handle chlorides. It's like, if you could find something, you'd be a very wealthy person. But yeah, it's very challenging. But there's a lot of different schools of thought. So up in Maine, folks are moving away from some of the permeable paver options because they feel like those chlorides just go straight through there, hit the stone and head out. Whereas in a green infrastructure system, you've got a little more resistance for that getting through. A green infrastructure system is not going to take those chlorides out. It's still going to eventually make its way to the groundwater table or wherever it needs to go. But I think it has some ability to reduce the concentration that ends up going. So most folks, I think, in that space focus on BMPs that generally slow the runoff down and have maybe a more finer treatment process as they work their way through, as opposed to hitting a storm drain and setting right out. And that's one of the biggest challenges with the permeable surfaces. Yes?
Snow removal maintenance. Can you give any insight into how to deal with those issues?
With regard to snow?
These BMPs become targets.
Yeah.
For snow removal after anti-skid and salt and everything has been applied pre-storm.
Yep.
Whatever. And do you have any insight into how to deal with that problem?
Yeah, I mean, I know my experience when I was working as a civil engineer and we designate the snow storage areas, right? Snow's going to go here. And then reality is the plow guy's like, nope. And hey, that's actually a little low area over there. I'm going to put it over there. Yeah, there you go. All right. Dang it. I guess it's not a comprehensive list. But yeah, the reality is we're foolish to think that we can protect a BMP from snow. Whether we put up a wood guardrail which gets hit with the plow and disappears, whatever it may be, snow will get its way there. And there's no doubt that when you're up in Maine or even parts here, that there's going to be a certain part of the year where those BMPs are more dormant. Obviously, the plants are dormant from that water quality part, the uptake. You should still get some filtering. I think a lot of the research shows that water still passes through those systems at a slower rate and is going to be more focused on sediment than it is nutrients and other kind of pollutants during that period of time. But generally speaking, I mean, that one at the Kittery trading post I showed that was right in that front lot of the parking lot, the first year I went out there, and of course, it was a low point, so everyone plowed everything right there, and there's this massive pile of snow. And by September, when it thawed, there was those plants were coming right back. So it's interesting. But you've got to, when you're looking at plants, you want to find obviously plants that are drought tolerant, that can handle heavy inundation, and then also have some ability to tolerate salts if you're putting these BMPs right on the edge of the pavement. And that's where a lot of these like beach grasses and whatnot do well, because they're used to a certain amount of salt. Yes?
In Philadelphia, with all the water quality filters they have, when they clean them out, where do they take them? It seems to me that would be to some yard somewhere where rainwater falls on the material and carries the pollutants right back into the Schuylkill River. What happens?
I actually don't know the answer to that. You
actually do know that.
Yeah, there you go.
I used to actually work for the Philadelphia Water Quality Maintenance team. They would dispose of it to a landfill in that situation. Yeah. I mean, waste has to go somewhere.
And one actually thing I didn't mention earlier is when they do these catch basin inserts they have, or these green inlets they clean those once a month, which is like kind of crazy, because I feel like when we often talk about, okay, yep, you're going to put in a rain garden. Yeah, you're going to inspect it twice a year, maintain it once, or maybe inspect it once every 10 years, maintain it every 30 years. We talk about maintenance a very limited amount, and maybe at the most we'll say, yeah, quarterly, you should go out and check the amount of sediment that's filled up in maybe one of the units that Contech or somebody like that has. You get into Philly or you get into New York City, and this is a weekly thing. In New York, they have crews that clean those right-of-way bioswales 3 to 4 times a week. It's like a totally different level, right? So when we were designing these filters, capacity of those inserts actually tied into how frequently they maintain them. So if you can add a little more capacity, now we're only cleaning them every, say, 5 weeks instead of 4. That's a huge savings on labor and equipment. But that's where it goes, landfill.
Annie, was that a requirement, or was that just something the city decided to do?
As far as maintenance, frequency of.
Taking it to the landfill.
I think that was just the most cost-effective option, and plus, in the city of Philadelphia, you're also dealing with a lot of other things besides sediments. So mixed in with your organic material is also a large trash load. So
A large trash load. It's from my experience, it's been more trash than it has been sediment. Cans, cigarette butts, these types of things. Okay, I think we're
If
good.
there's not any more questions, big round of applause for Rob.
Thanks, guys.
We're going to take a quick 15-minute break. We have Robin Engelmeyer from Strasbourg Nature is going to be here next. So if we want to reconvene back here at 10:15, and we'll start you guys off with a raffle. So,
Thank you.
thank you.